Good afternoon and welcome to your Science Review with Mr. Blades. We're going to start off by writing out our knowns. So we know that at the very top our velocity is 0 and therefore our kinetic energy is 0. We know at the very bottom our potential energy must also be 0. And now let's go ahead and start calculating the things that are pretty easy. The potential energy at point 1 is equal to mass times the acceleration due to gravity times height, or 50 times 9.8 times 4. And that gives us 1,960 joules of energy. And since there is no kinetic energy, we know that the total amount of mechanical energy at any point in the entire roller coaster must also be 1960. So we can just plug that into every spot along the roller coaster. Next easiest is probably calculating the potential energy at point 2. Same equation, mass times acceleration due to gravity times height, or 50 times 3 times 9.8, and that gives us, I had to check, 1470 joules. And since our mechanical energy is just equal to potential plus kinetic, we can solve for our kinetic energy just by subtracting potential energy from the total mechanical energy, or 490 joules. This lets us plug our kinetic energy into our kinetic energy equation, 1/2 mv squared, and we can solve for v using the square root of 2 times the kinetic energy over mass, which in this case is equal to 4.43 meters per second. Now down here at the bottom, we know that since our total mechanical energy is 1960 and our potential energy is 0, that the kinetic energy must be 1960. And similarly, we can plug in our 1/2 mv squared equation, just like we did a second ago, and solve for the maximum velocity, in this case, which is the square root of 2 times 1960 divided by 50, which equals 8.83 meters per second. Last, we are given a velocity, so we can calculate our kinetic energy there. 1/2 mass times velocity squared, or 1/2 times 50 times 6 squared, which is equal to 900. And just like we did before, we can subtract that 900 from our 1960 and solve for 1060 joules of potential energy, and use our potential energy equation to solve for the height. mgh, or 1060, is equal to 50 times 9.8 times the height. Divide both sides by 50 times 9.8, and we end up with a height of 2.16 meters. Now we've solved for this entire thing. I hope this was helpful, and I'll see you in class.